All right, students, this is lesson 631, properties. I know you've done a lot with these properties already, and some of this might be review, but we're hoping at this point you really get to learn them well. So here are all the properties, some of the properties listed. The important ones are the commutative property of addition and multiplication. And the key there is that changing the order of the factors does not change the product, or changing the order of the numbers in the sum does not change the sum. And you can see some examples of that. Basically, you can switch them around. I actually had a student one time that called this the switcheroo property. And so another important one here is the associative property of addition and multiplication. And that's where you can change the grouping of the numbers you're adding or the factors in a product, and it won't change the outcome. And just a quick example of that, let's say I have to do 3 times 10 times 9. Normally you would do that in order from left to the right, and you would do 3 times 10 first and then times 9. But if you want, you can do 10 times 9 first. It's not going to change the product, which is 90, and then multiply that by 3. And you'll get the same result. So you can either do 30 times 9 or 90 times 3. All right, some other properties that are important, identity properties. Those are the properties that allow you to get the same thing back. So in multiplication, think about this. What number times 10 gives you 10? And that's 1. And that's the identity property of multiplication. And in addition, what number plus 10 gives you 10 back? And that's 0. And then some related properties, the 0 property of multiplication. Whenever you multiply by 0, you get 0. And the multiplication property of -1. Whenever you multiply by -1, you get the opposite of the number you started. All right. Here's another look at all those properties, and we put it at the top of this page, so as we're doing these problems, you have a place you can go back to look. So what property is illustrated by each statement? Notice in here we're multiplying by 0, and one thing you should do when you're trying to identify a property, make sure you look at the operation we're using and what's going on. So we multiply by 42 times 0 and we get 0. So it has something to do with multiplication and something to do with 0. So that's a big hint. And if you look here at the 0 property of multiplication, you'll see that that's what's happening. Multiplying a number by 0 and you get 0. Okay, the second one has something to do with grouping, it looks like, because there's some parentheses. And notice that the parentheses are changed in this one from around the y and the 2.5 to the 2.5 and the 28. And when you change the grouping, that is the associative property of addition. The next one, we are taking something and adding 0 and getting the same thing back. That is the identity property of addition. So we got a couple more here. Let's think about these. Here in number 1, we're multiplying 4x times 1 and we're getting 4x. So we are getting the number back that we started. And you can go back here and look. But here it is right here. 1 times a is equal to a. So we're not getting 0. We're not getting 1. We're getting the number back. And that's the identity property of multiplication. I'm going to abbreviate some things here. Let's check out this next one here. This one appears like it has grouping symbols, but as you look more closely, the same two numbers being added in the parentheses they remain the same, and x is still outside here. So it's not we're not changing the numbers that we're grouping. We're actually switching around the numbers inside the parentheses, and when you switch them around, that is a commutative property. And that's right here. So switch them around, you get the same thing. So we're going to say commutative property of addition. All right. We can use properties to help us simplify things. Oftentimes, there's certain numbers that are easier to add or multiply, and so we can use the commutative and associative properties to pick whatever would be simplest. And if you look at this example here, we want to add 7.75 plus 2.40 plus 1.25. And in itself, you might say, well, I'm just going to use a calculator to do that. But if you didn't have a calculator, you might notice that that this number and this number would be easier to add together because 0.75 and 0.25 make one whole dollar. And so what we might think about doing is switching around the order and switching around the grouping. When you switch around the order, that's the commutative property. When you switch around the grouping, that's the associative property. And that makes it a lot easier to add. Adding the 7.75 plus 1.25 makes 9. And then you just add the 240. Then you can just add 9 plus 2 is 11 plus 40 is 1140. So let's look at another problem like that here. A can holds 3 tennis balls. A box holds 4 cans. A case holds 6 boxes. How many tennis balls are in 10 cases? So really what we have here is if we just had 3 tennis balls and 4 cans in each, 3 tennis balls in each of those 4 cans, we would want to do 3 times 4. But now we have 6 boxes, and in a box there are a case holds 6 boxes, so in these 10 cases are 6 boxes, and in each box are 4 cans, and in each can are 4 tennis balls. So we really need to multiply all these things. And because of the associative and commutative properties, you don't have to do this in order from left to right. You can do it in any order you want. And so you can pick the numbers that are easiest for you to multiply and do those first. And so, in my head, I'm thinking, well, let's see, we have 10, and times 3 is 30, and then 30 times 4 is 120, and then 120 times 6, 12 times 6 is 72, so 0 makes 720. And by switching these around and choosing the ones that I want to multiply by first, that's using the associative and commutative properties of multiplication. All right. So we're going to name each of these properties. And I think we'll do that in class. And we're going to also do some simplifying of some expressions here. And I'll just show you how this works a little bit here with this example, and then I'll do one with you. But right here, we want to simplify this. 7t plus 3 minus 4t. And what you should notice is there are some like terms there that can be combined. And really, the reason we can do that is because we can rearrange the order and the grouping by using the commutative and associative properties. So here we wrote the original statement right here, and we rewrote it by just switching around the numbers inside the parentheses. When you switch numbers around, that's the commutative property. And then we regrouped it, so we combined the 7t and the negative 4t in one group, and then the plus 3 outside there. When you change the grouping, that's the associative property of addition. And then notice that both of these are times t, which means we can write it a different way using the distributive property. That's 7 plus negative 4, added first and then times t. And 7 plus negative 4 is 3. And when you rewrite an addition and a multiplication like that, that's the distributive property. and then just adding 7 plus -4, we're just going to say that's simplifying. All right, here's another example you can check out. Let's do one here together, and then the rest of these we'll do in class. So let's do number 11. 6 plus 8x plus 12. All right, that is equal to. Now, what I'd like to do is have the 6 and 12 together so I can combine those. And I can do that if let's first rearrange what's inside the parentheses. So I'm going to have 6 plus 12 plus 8x. And that's the commutative property of addition. Just switching around. Okay, and then let me move this down. All right. So we have the commutative property of addition. Now I want to add the 6 and the 12 together first, so I'm just going to regroup it this way. Plus 8x. And when you regroup, that's the associative property of addition. And 6 plus 12, we're just going to simplify that to 18. And that is just simplifying. And we can't go any further because we don't have like terms here. There's no properties that will help us simplify that anymore. All right? I think we'll call that the end of this lesson, and we'll do the rest of them in class. See you tomorrow.